Welcome to the second part of my income distribution series about descriptive statistics. In the first part, I talked about relative frequency tables, histograms, cumulative frequency tables, and ogives. And of course, all of it was done in the context of the income distributions of female full-time employees in Switzerland. In this second part, we will focus on calculating the mean of such group data. So here's an Excel sheet we produced in the last part. Remember, here's a group data of, again, female full-time employees in Switzerland 2020. We have the different classes, the different ranges of monthly income, and the corresponding relative frequency of the group. So in other words, maybe we look at this one here, 12% of all female full-time employees in Switzerland get between 3,001 and 4,000 Swiss francs per month. Last time we did the histogram on the right. So you see it's a typical income distribution. And then we did the cumulative relative frequency tables where we take these classes starting at 0 and going to up to a certain point. And the graph of it, which is called the ogive, which is, of course, an increasing function. Today, we want to calculate the mean. And before we look into the calculation of it, we need to talk a little about some assumptions. And what we need to simplify the data a little. So let's look at this. Maybe we remain in this class here. So 3,001 to 4,000 Swiss francs. So of course, that means some of these 12% of all females get 3,001, some get 3,010, 3,050, 3,500. So we don't really know how much each of them makes, but we need to make an assumption about the average income of persons in this class. And the simplest assumption is we just say the midpoint might be the typical income. So what we do is we add a column here, which are the so-called midpoints. The midpoints, of course, are the midpoints of the interval. So 0 to 1,000, midpoint is 500, meaning these people, we treat these people as if everybody would get 500 instead of not knowing how much between 0 and 1,000 they get. And of course, here it's 1,500 and so on. So again, I can speed up a little, filling out this table by just highlighting the first two entries, grabbing this handle, pulling it down. And again, Excel will understand what I'm doing. And you see all these numbers are the midpoints between these ranges. And by the way, of course, 3,001 doesn't really mean 3,001. It means anything a little higher than 3,000. So even if 13,000. So even if somebody gets 13,001 cent, they would fall into this class. So the midpoint 13,500 makes really sense because it's really the midpoint between 13,000 and 14,000. The last class is a little tricky. What is the midpoint of this class? It's an open-ended class, so some of them make 100,000 per month. Some of them might make 1 million per month. Well, very few. What is the midpoint? What is the midpoint? There's no midpoint of this class. So what we need to fill out here is a typical income of these very high achievers. So the 0.8% of all female full-time employees in Switzerland get more than 20,000 per month. So that's good. What is a typical income? And here, of course, we can only guess. And I don't know, maybe I'm guessing it's 25,000. Maybe it could be 30,000. Maybe it's 22,000. I don't really know. And of course, what we should do at the end maybe is to play a little around and see whether this number really affects the mean, and we will see it does not affect it very much. Okay, next I want to talk about average and weighted average, because for this kind of data we need a weighted average. Let's just start with average. Let's say we have 4 persons making 2,500, 3,500, 4,500, 5,500. What is the average? Well, it's not very difficult to estimate. The average of 4 numbers is the sum of the numbers divided by 4. So we add all these 4 numbers, divide by 4. But for our purposes, I want to rephrase it a little. So I want to write it as 1/4 times 2,500 plus 1/4 times 3,500 plus 1/4 times 4,500 plus 1/4 times 5,500. So we multiply these values by certain numbers and add these products to get the average. And of course, it's 4,000. It's a value in the middle. That's not very surprising. Okay, next, if we have large population and 25% of them get 2,500, 25% of them get 3,500, 25% 4,500, and the rest 5,500. So in a sense, we have classes, we have group data, but we have each group the same size. So let's assume we have a population like this. What is the average? And it's pretty easy to see that the average in this case must be the same as before, because these groups have equal size. So what we do is we do the same calculation as before, but I want to replace the 1/4 by 25% to emphasize this 25% comes from the percentage of the group size. So the group size is the group ratio, in a sense. The relative group size is multiplied by the income. So we get this product, and of course it's the same as before, it's 4,000. Okay. Next, we need to go to weighted averages. So weighted averages are not averages really, but again, a little different. So let's assume we have still 4 classes and 70% of the population gets 2,500. And 10% 3,500, 10% 4,500, and 10% 5,500. And that means, of course, that now the low income group has a much larger size than the others. And that means, of course, that the average for the whole population must be lower than before. So it cannot be 4,000. Cannot be 4,000. Must be much lower. And again, maybe approaching the 2,500. Of course, it must be more than 2,500. So how do we calculate it? And the formula is actually very simple. And what we do is we multiply the income by the relative frequency of each class. So the first class is 70% relative frequency, so we multiply 70% times 2,500. Remember, before it was 25% because this was a relative frequency, but now it's 70%. And then 10% times 3,500, 10% times 4,500, and 10% times 5,500. And the result is 3,100. So this is the average of such a population. And this is a formula we will use in our Excel sheet. It's a very important formula, the weighted average formula. It's related, in a sense, to expected value of a experiment in probability theory. It's more or less the same idea. Now moving back to our example, let's now calculate this mean for this population. What we take are the midpoints, and what we take are the relative frequencies. And what we look at are the products of these two numbers. So remember, what was 70% times 2,500 in the previous example is now for the first group 0.2% times 500. And I want to do these products here. Maybe I label the column as products. So products of what? Products of relative frequency and the midpoints. And I put in a simple formula. I say I want to have this value. So again, I click on this value to make the reference. It says B4. So I'm saying I want the value which is written in B4. and want to multiply it by the value in C4. And again, I don't type in C4, I click on it. Simpler, if you click on it, it goes in, and this is your product. This is your first product. And remember, the weighted average is a sum of the products of relative frequency and midpoint. So what we do is we do all these products in this column, and eventually we do the sum of this column. So very simple. This is my first one. 1 point, funny number, 1.010101. And again, I don't repeat this formula. I don't type it in again. I can just put it down. So I grab this handle here, put it down, and go just up to the end. And as you can see here, as you can confirm, if I double click on it, each of these cells is just a product of the two cells to the left of it, as it should be. So here it's B17 times C17, and so on and so on. So we have all these products. And what we want to do is we want to make the sum of these products. So we do it here. Again, how do we do this? AutoSum again. Remember AutoSum. And we click on this one. And Excel says, do you want to add these numbers? And yes, that's exactly what I want. So you should always check whether the range is correct. Click Enter. And here is my average income of female full-time employees in Switzerland 2022. So I highlight this one. 6,209 Swiss francs per month is the average. So maybe I label it below. This is my mean. Okay, I promised you to show you how this assumption on the 25,000 for the richest group would affect the mean. So let me play around a little. 25,000, 6,009. What if this would be only 22,000? So remember 6,209, 22,000. Of course, it goes down a little, but it doesn't really go down very much. 6,184. So it goes down by about 25 francs. If it would go to 30,000, what about then? So if this group makes an average on 30,000, then my mean goes up. So of course, this assumption affects things. So we have to be a little careful here, but it doesn't really affect it too much. And of course, we have some assumptions in this anyway. Next, I want to calculate a little the gender pay gap. So you all know that women usually get paid less than men, and it is called the gender pay gap. And I want to calculate it for Switzerland for 3 years, maybe 2020, 2012, and 2006, just to see whether this gap did close in the last years or not. And it's now pretty simple. On this sheet here, I prepared data. Again, this is not the data given by the government. I changed it a little, so we have to be careful in such a way that these numbers add up to 100%. Usually they don't because of rounding errors, and this makes life a little more difficult. So I adjusted it in a sense, stretched it, that these numbers would always add up to 100%. Okay, these, again, the classes here on the left. And here I have 6 columns: female 2020, male 2020, female 2012, male 2012, and the same for 2006. So this first column was the data I have used to get the number, and maybe I should fill in the number already in my table, because here I want to make a table with the averages for female and male for the different years, and also how much less women make than men and how much more men make than women. And this is not really the same. These percentages are not the same. All right. So let me copy this formula in. So I'm copying this one. I'm going to sheet 2. And this was female 2020. This belongs here. I'm pasting it in. And I don't use the ordinary paste command. I'm right clicking and going to this special paste where I only paste in the values. And maybe here I should format it a little that the digits, the decimals don't show. So, I mean, this is really too much. So this is maybe the best way to display this. All right. Mail 2020. All I need to do is I need to highlight this column. I copy. I go to my machine, my average machine, and I put this one into my column for the relative frequencies. I can do as whatever. I can use the ordinary paste here because these are not formulas. So I can just paste it in. And you see the histogram did change a little. And the mean did change. So here's the mean, 7,385. So I'm copying it and I'm pasting it in here. So again, paste special and eliminating the decimals. So what is a gender pay gap? How much do female get less? How much do male get more? Well, for this formula, what we do is we look at the difference between both and we divide it either by the average for the males for this column, or we divide it by the average of the females for the other one. So this formula here would be, I'm typing in, I'm open parentheses, I'm doing the difference. So this is this one minus this one. This is a difference of average income, and you divide it by the average income of males. So the difference divided by the male income would be how much female get less than men. So I type this in, and what do I get? I want to see it in percentages. I click on it, I put in percentages. Maybe one decimal is good. 15.9% less. So female get 15.9% less than male. 2020 Switzerland. How much more do men get than women? So the formula is a little different. It's still the difference between both. So I'm doing this one. Difference between male minus female divided by the female average now. And you see the number here. I also want to have percentages and I want to see one decimal. So 18.9% more. So the men make 18.9% more than women, and women get 15.9% less than male. So this is, again, depending on how you view this, how you express this. This is a gender pay gap 2020, so still a very high number. All right, let's do it also for 2000, or maybe for time reasons we just do 2006. So let's see whether we had different results in 2006. So I'm going here, copying sheet 1, paste it in. So this is female 2006, 5,000, so relatively low number. I copy, I paste it here. So here's my number. Again, I want to see less decimals here. And then the males 2006. So I'm going here, grabbing it, copy, and sheet 1. I paste it in. What do we have? 6,534. Copy, sheet 2, paste, delete decimals. And here These two calculations we can just copy and paste again. The references will shift automatically, so there's nothing really fancy here. I'm just copying this formula, click on this one and paste it in. So you see it was 21.9% in 2006 and now it's only 15.9% in 2020. And of course this number is probably also much higher than it is now. So let's go. It was 28%. 28% pay gap again, 28 or 21.9, depending on how you express this gender pay gap. Okay, that's it for today. So if you are interested in descriptive statistics, then please go to the next video, Income Distribution 3, where we will do the same for median. If you are interested in the mathematics of inequality, Robin Hood index and mean, and Lorenz curve and Gini index, then please proceed to income distributions 4 and eventually number 5. Thanks for listening. Bye bye.